In this project, we'll fade up and then fade down the brightness of the entire LED strip. Anytime we're using the LED strip, we want to include the LED strip.h library. That gives our code access to special functions that make it easier to program the strip, like setPixel, draw, and clear. To use this library, we have to name the LED strip, and I named mine strip because that's easy for me to type and easy to remember. And we complete this LED strip function. The function has 3 arguments. First, how many pixels are on our LED strip? Second, which pin of MakerBoard is plugged into the green wire of the LED strip? And third, which pin of MakerBoard is plugged into the blue wire of the LED strip? The void setup function doesn't have any code between its curly braces, but we still need to have this function here, even if it's empty, for our program to work. Within the void loop, the first thing you see is a for loop. The for loop has 4 main parts. First, you create a variable and give it a starting value. Next, you create a condition that is checked each time the for loop runs. Third, you create a change to the variable that happens after the code between the curly braces runs. And fourth, you have the code between the curly braces that runs when the condition of the for loop is true. In this case, we're creating an integer variable, which means it's a whole number value, and it has the name I. I is a common name to use for a counter variable inside a for loop. The starting value of I is 0. The condition that gets checked is I less than 100? If that's true, the code between the curly braces runs, and then I++ increases the value of the I variable by 1. Inside the curly braces of this for loop, you'll see a setPixel function. That has 3 arguments. The first argument is which pixel or pixels do you want to address. We want the entire LED strip to turn on, so we're using strip.all as the argument in this function. The second argument is the color value on that pixel or pixels. This can range from 0 to 299, and we're using 200 to show the strip as green. And third, we have the brightness argument. This is like a percentage, so it can range in value from 0 for no brightness at all to 100 for maximum brightness. And in the past, we've used a number in here like 10 to set the pixels on the LED strip to a 10% brightness. In this case, we're using the value of the I variable to determine the brightness on the strip, and the I variable is going to change each time the for loop runs. The .draw function is going to display our set pixel data on the strip, and the delay function with an argument of 50 is going to pause the code on line 16 for 50 milliseconds, or 0.05 seconds, before moving to the next line. After the delay, the program reaches the closing curly brace of the for loop, and it's going to jump back up and run this I++, increasing the value of the I variable by 1. Then it will check the condition again, and if it's true, run the code between the curly braces again. If the condition is false, the program skips the code between the curly braces and continues down the void loop. In this case, there's another for loop in this void loop, and this for loop has the same 4 parts: creating a variable and giving it a starting value, creating a condition that checks that variable and decides whether or not to run the for loop, a change to the variable that runs after the code between the curly braces runs, and the code between the curly braces that runs when the condition of the for loop is true. Just like in the prior for loop, we're creating an integer variable called I, and this variable I has a starting value of 100. The condition checks if I is greater than or equal to 0. And if that's the case, the code between the curly braces runs, and then I minus minus runs, subtracting 1 from the value of I. Inside this for loop, it looks exactly the same as lines 14, 15, and 16. We're using the setPixel function to set the entire strip to a color value of 200 and a brightness value of I. We're using strip.all to address the entire strip, give it a color value of 200, which is green, and set the brightness of the pixels to I, our variable. Then, the draw function displays that setPixel data, and there's a delay of 50 milliseconds on line 24 before reaching the end of the for loop. Let's run through how this code is going to work. You have an integer I that starts at 0. 0 is less than 100, so the condition is true, and the code between the curly braces is going to run. The setPixel function is going to set the entire LED strip to a color value of 200 and a brightness of 0. So we're not going to see anything on the LED strip when strip.draw runs because the brightness is at its minimum. The program delays for 50 milliseconds before reaching the end of the for loop and increasing I by 1 with I++. Now I equals 1. 1 is less than 100, so the condition is still true and the for loop is going to run, setting the entire strip to a color value of 200 and a brightness of 1. So when strip.draw runs, we will see a very low light on the LED strip. After a short delay, 50 milliseconds, the for loop reaches its closing curly brace and increases I again. Now I is 2. This for loop is going to run 100 times until I equals 99. Then the setPixel function will set the entire strip to a color value of 200 and a brightness of 99. Strip.draw will display those bright pixels, and a delay of 50 milliseconds will pause the entire strip lit up with a 99 brightness. When the for loop ends here, it will run I++, taking the I value from 99 to 100. 100 is not less than 100, so the condition is now false. Your program will skip the code between the curly braces of the for loop and continue down the void loop to line 21. When the second for loop starts, it's creating a new variable I and setting it equal to 100. 100 is greater than or equal to 0, so the code between the curly braces will run, and setPixel function will set the entire strip to a color value of 200 and a brightness of 100. When strip.draw runs, we will see the LED strip lit to its maximum brightness on all pixels. After a delay of 50 milliseconds, the for loop ends and runs I minus minus, subtracting 1 from I, and now I is 99. 99 is still greater than or equal to 0, so the code between the curly braces will run again. This will happen 100 times until I equals 0. When I equals 0, the setPixel function will set the entire strip to a color value of 200, but a brightness of 0. So it's going to be off when the strip.draw function runs. We won't see any color at all. After a delay of 50 milliseconds, the for loop reaches its closing curly brace, and it subtracts 1 from I. Now I has gone from 0 to -1, and -1 is not greater than or equal to 0. This for loop is completed and the code between the curly braces is skipped. Then the program is going to reach the end of the void loop with this closing curly brace on line 26. It'll jump back up to line 13 and reset an integer I to a value of 0, starting the brighten for loop again. Because your for loops are taking the brightness from 0 to 99 and then from 100 down to 0, this is going to fade the brightness really smoothly on your LED strip, up and down continuously. And the for loops are going to run 99 times for this first for loop and 100 times for this second for loop before the void loop has completed even once. So the for loops are going to continuously run until the conditions are false, not allowing the code to check anything else that's inside the void loop.